Mayor, do you have the question?
I think it's not only Macmillan is not doing it. Cannot display PDF.
What?
Christmas pattern. I can't focus on lesson anymore.
Try to focus on the lesson. We'll do a little bit of electricity and then we'll go to the Christmas party. That's all.
When will we go like that?
Seems so much fun. Sounds
Just relax. You'll go. Don't worry.
When
When I'm ready.
when you're ready.
I don't know yet. What's up?
we're not going forward.
Oh, why is that now? Not cool enough for you?
No, to be honest, I was told that like you and Doreen are not going, so like who's gonna-
I'm going.
Yes, but now you said you're going, but I already, have made plans with a friend and him to go with this and that, so.
Oh, I see. It's like that, is it? So I only have 2 physics students to take?
Oh.
Breaks my heart.
I didn't want to go because you and Doreen didn't.
That's
didn't
okay.
want going, so.
More fun for us. That's okay.
I'm too cool for.
No, that's okay. You know what? I think we'd be happier without you there. All right. So you have the diagram there. How big is the cell? Oh, thank you. Can you give me the numbers, please, for all? 8 volts. And is there a resistor here?
Oh, 5. What is that called?
Resistor. Oh, fun.
English proper.
Yes, English problems. Okay, and we have 3 here.
2.
Only 2?
Oh, no. 3.
Yeah, 12, 3 to.
12,
3,
3, 2.
Determine the total resistance and the torque.
Well, that's easy peasy. Lemon squeezy. 1/2 plus 1/3 plus 1/12. That is, let me see, that's 6, and then 4 is 10, 11/12. Yeah, so the total resistance is 1/2 plus 12/11. This is the 1/2 here. I didn't make a mistake, did you, Fawn? 1.59 ohms. Did you get that, Miss Sharif?
Yeah.
Yeah, great. What's the next part?
Determine the
The current flow through the 0.5 resistance.
Easy peasy. So here is I. So you have VI OR. So I equals V over OR, which will equal 8 over 1.59, which equals 16? No?
you divide 1.5, it's just 0.5.
No, it is not.
Why?
It's not. I'll tell you now. So the reason is, here, this V is for the 8, yes?
Yeah.
That is the total V. So you should use the total OR. If you only use 0.5, then you need to use the voltage here. But you don't know this voltage. So, I'm afraid this is the right answer. Yeah.
176 over 55.
Could be. Yes, it is. What's part 3?
P. The
Which-
power.
Of which?
Two resistance.
This one.
Yes.
Now, you have a couple of choices here, because remember we have P equals IV. Although we don't know the I and we don't know the V, we do know the OR. So we can say V equals I OR. I think I'll go with then saying I equals V over OR. And I put that in here. And then you get power equals V squared over OR. Now the good news is I know what the OR is. The bad news is I don't know the V because I don't have the measurement here. But I can know the V up here. Look, what's the V here? IOR, which will be 0.5 times 1.59, which is 0.795. So if that's 0.795, then what's the voltage here? How do I get that? How do I get that? Anybody? Oh, come on. If I know this voltage, then what's this voltage here?
Oh, minus the...
From what?
This minus 8.
Yeah, minus from 8. So the voltage will be 7.205 squared over OR. 26 watts.
But why you multiply 0.5 by 1.5?
IOR. V equals...
5.5, but 1.59.
No, the I is 1.59. I just wrote them backwards. The OR is 0.5. Yeah? No? Oh wait, hang on. No, my mistake. My mistake.
Multiply to R.
No. Guys, wait, look up please. What's the I here? It's not 1.59. Is that the door?
Yeah.
Come in. Ah, Mahmood, where were you?
We were in the GNIB.
You're finished now?
Yeah.
Great. Sit down there, so. Sorry, what was the I? Guys! What's the I? There it is.
Yeah.
So I should have had 5.03 times 0.5. That's better. Right, is this what you're asking? So that is 2.515. So then the V will be 8 minus that. 5.485 squared over 2. 15 watts. Is that okay, Flan?
Yeah, I'm wrong in the question 3.
In which part?
3.
Okay. It's okay now? Yeah. Okay. What's the next one? Do I need to open it? You have it? Oh, it's working on your phone.
I have to delete something.
What did you delete?
Photo?
Photo. Sad photos? Happy photos?
Lovely photo.
Lovely photos, oh no. Okay, what's the next one now? Do you have this, Ms. Sharif?
11.
Not yet. 11?
No,
What's the
I-
difference? 6?
I-
The next?
A high resistance voltmeter connected
yeah, I don't know how to do
across.
that.
Alright, we'll wait until Ms. Sharif just writes this down. Did you write this down? GNIB was okay? No problem?
No, I was going to ask about the passport because it was for a long time was there.
What do you mean it was there?
My passport
Yeah.
was there.
In GNIB?
Yeah, and I need to go next week. I must go to Dubai.
Oh, okay. You have your visa?
What?
Visa?
I'm waiting for the re-entry visa.
You're waiting for it?
Yeah.
Okay. No, you got that? Right. So go ahead, Adnan.
High resistance voltmeter is connected directly across the terminals of a cell, and the potential difference is measured at 3.5 volts.
Okay, let me just draw that now. So here's the cell, and you're saying that you put a voltmeter around it, and it measures as 3.50.
3.50.
Okay, and then next?
A 6 ohm resistor is then also connected across the cell terminals, and this causes the voltmeter reading to fall to 2.40.
Okay, hang on. So how big is the resistor that you said it's connected?
6 ohm resistor is then also connected.
Okay, and now the voltage is what?
2.40.
2 Okay. And the question is, what's the internal resistance?
What is the EMF of the cell? That's number 1.
Okay. Okay, can we do this one? Yeah? Yeah? Okay, so here the cell has an EMF of E, an internal resistance of small r. And here it's still E, and this is small r. What rule could we use here to help us? No. No. Give me his name. He's your favorite. He's from Russia. Kirchhoff, our man, Kirchhoff. Which rule? His loop rule or his junction rule? I give you a clue. There's no junctions. So, loop rule, correct. So, if we start here with the E, and I go to left, right, up, and then back here, I have E minus I, sorry, there's an I here. Yeah. But this isn't really any good, because there's so much here we don't know. But in fact, this particular diagram, where are you going? Are you going out to leave the classroom? You better not be. Right, this rule here is not useful because there's so much that we don't know. Yeah, so let's just leave this one for the moment and have a look at the next one here. Well, no, you know what? No, I will continue with this one. Now, do we know what the OR is? No. Do we know what the I is? No. Well, do we know what the E is? Well, we kind of do, because we have the voltmeter, and the voltmeter is around this. And what does the voltmeter say it is? 3.5. So we could say 3.5 equals I OR. Yeah? But of course, the problem is we don't know what the I is. If we knew the I, we could get the OR. Is it the OR that they're looking for?
Yeah.
They're looking for the E. Is that it? No, I think I'm doing this wrong then.
I think we should use the EMF equal IR plus I small r.
Use this formula? But I like Kirchhoff. Okay, we won't use Kirchhoff then. What's the formula again? Is E equals I or plus or, isn't it? Like this? Okay. Well, that's kind of the same as Kirchhoff, because what's the big or here? It's 0.
Yeah.
So it's the same as Kirchhoff, yeah. But we can use it here.
Yeah.
So we get E equals I. You know what? This isn't so bad, because then this will be 6 plus or. So, how many equations? 2. How many unknowns?
2, 3.
3. What have we not used yet? The volts here, yeah. We haven't used this yet. Okay. I'm sorry. I'm doing this wrong. I have the idea in my head, thinking.
It's not gonna be in the process.
I'm thinking. Now, I need to redraw, look, I need to redraw this one. Look. So here I'm going to redraw it like this. The 2.4 is down here. Do you remember in class we talked about how here is the same as here because you can just move the wires? But this is the I, this is the OR, this is the V. So can we know the I? We can by using VI OR. So let's calculate the I first. I is V over OR. Yeah, so we get the I is 0.4. Whoops. So here the I is 0.4 amps. Going this way and going this way then. Got that? Okay. Now, this here is E. This here is OR. Are you sure they want the E? Double check. Are you sure it's not the OR?
Maybe.
We want
What
to
is
determine the
E
thermal
and
resistance.
Ah, they want E and OR.
Yeah, that's.
Okay, fine. Yeah. So, I really think the E is just 3.5. How many marks for the E?
1 mark.
Oh, what the? Well, then it is 3.5. Yeah, it's only 1 mark. When you put the voltmeter to the cell and there's no resistor, then the voltage here will have to be the voltage on this one because it's only this one. Yeah, 1 mark definitely.
Can you repeat please?
Yeah, there's no resistor here.
Okay.
Agreed? So the voltmeter's reading is only for this one here
Okay.
because there's no resistor. Does that make sense?
Yeah.
So it's just 3.5 then. Now, here we know the I. So if I use Kirchhoff, can we do Kirchhoff together on this one? What's E? 3.5 minus
2.4.
2.4 minus, I'm starting here and I'm going around. So what's the next one?
Or E.
Let's start this again. E, yes? Minus
2.4.
2.4 minus
RI.
I OR. What's the I?
0.1.
Yeah. Is that okay or not? I'm not sure. Is that okay? I know that was a bit weird. I got confused because I made it harder in my head. Then when you told me it was only 1 mark, I realised I'm making it too hard in my head.
Why is that? Why is that?
This was part A and this was part B.
B is explained.
Oh.
Oh, this
Yeah,
is C.
this is C, this one is C. Yeah, B is C. Because there's B that is explain why the terminal potential difference falls when the resistor is...
Oh, okay, that's C.
Yeah.
Oh, well, what is the reason that it goes from 3.5 to 2.4?
The resistance there.
Yeah, the resistance here, this is using some of the volts. Yeah?
But part B is still works, so it's like, that's it.
Make it a sentence at least, then just use voltage, that won't get you 2 marks. Fuan, did you get this question when you tried it?
No, I don't know the question.
You didn't do it? Okay. Musharif?
I get until I equal 0.4 and then I didn't know what to do.
Good man. Okay. So you got, so you didn't get this equation.
Yeah.
Yeah, so you didn't use your friend Kirchhoff. Yeah.
Because I don't know if there are relation between.
You can always use Kirchhoff. Kirchhoff is number one for electricity. Kirchhoff is like Newton for electricity.
Right now.
No!
I'm not
But that's not a good thing though. Yeah. Don't be such an ad man. Right. Can we go to the next one? What's the next one there?
11.
11. Okay, go ahead, Fuan. Go ahead. No, read it. We all like to hear you read, don't we?
No.
Don't we?
No.
We like to hear Fuan read.
No.
Go ahead.
Over 8 meter. Then
Hang on. Guys, I can't hear Fuan.
Sorry.
Wait, are you ready?
Yeah.
Now listen carefully to her. Alright, start again.
over 8 meter. Then magnesium white
Yeah.
has a resistance of 7.744 resistance and
7.744
Mhm.
resistance.
But there is a 7 before it.
Huh?
what?
What?
Yeah. I think you.
Oh, we skipped the question. 7.
No, it's
What?
not electricity.
No, we're just doing electricity. Yeah. Okay, this is ohms?
Yeah.
Yeah, okay.
And the resistivity
Yep.
of magnesium is 4.8 to multiply 10.
No, Fuan, you know this word. You know this word.
I forgot.
No, you couldn't have forgotten again. Not again. What is the word?
Bye.
No.
Why is it fight?
No.
E.
No. Power.
No, it's not power.
Who's that power?
Yeah, it is power. 10 power
Minus 7.
minus 7.
Power.
Yes.
You can say 2. Yeah.
2.
2 minus 7. 10 to minus 7.
You can also say 2, yeah.
Yeah.
To the power of minus
2. 2. Okay.
Okay. What's the unit? It's a ohm meters.
Meter.
Okay.
Determine the diameter of the wire.
The what is the wire?
the diameter of the wire.
Diameter. Okay. So first we use this formula. Do you remember this?
Assuming
Circular.
Circle across.
No, I got it. It's okay. You've given me enough. Thank you. Right. We need to use this formula. Do you remember this formula? Yeah. So we have 7.744 equals 4.82 times 10 to the minus 7 times 0.8 over pi or squared. What's so hard about that? Nothing.
How can we do it then without the calculator?
Why are you asking such a question? You use the calculator in the exam and it's your friend.
Like moving.
Oh, okay. You mean in other words how to solve this? You just need to swap these two.
That's it.
Yeah.
Really?
And 7.
Yeah. Okay, so 4.82 times 10 to the minus 7 times 0.8 over 7.744 times pi. So I get r squared equals blah 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 blah, and then I just do square root. I know, thank you. The r equals 1.259 times 10 to the minus 4 meters. So the d will be 2 times this. You mean what?
Why my answer is O pi over
0.252 millimeters.
Even
Yeah.
I forget about 0.7 turn to 1 to 0.7. I multiply 4.8 to
Yeah.
2.9 over 7.744
Yeah.
to 5,
Yeah.
and then I put 10 to minus 7, and I get different number.
different number.
Maybe I made a mistake. 4.82 times 10 minus 7 times
No,
0.
no, no. Forget about.
No, I want to double check my answer and then we'll check yours. Now please, oh. This is after the square root. This is after the square root. No,
Yeah.
yeah, I'm taking a shortcut. I'm not writing the number down. What did you get?
O pi over 8.
I get 0.397 multiply 10 to minus 7.
Did you put in the pi there?
Yeah.
That includes the pi. I don't know. I think you might have to check again. But you know what? We have the answers. We can just check the answers and see if we're right. Is there another part to this?
No.
It's the D, not the R.
That's the D. 0.2.
No, 2 pi the I.
What?
The I.
This
The
A.
formula of
It's
the
pi
I.
r squared.
Formula of the I.
Yeah.
What is the formula?
There. It's right there.
But,
But what? This is it here.
yeah, Y is R.
That's the formula for the
The
A.
formula is
Pi r squared.
no.
Yes.
It's pi D over 2 square.
That's the same thing.
That is different number.
No.
Different answer.
This is the same as this. All right. We'll open up. No, don't do that. I hate when students do that. The question was what's D?
Yeah, but I tried the answer.
Good, fine,
Yeah,
yeah. And then you got the D.
Yeah, but it's different.
Okay, shouldn't be. Look, it's simple. We'll check the answer and we'll see who's right. Now, I know I'm not always right. I know I'm not perfect, but I think this time I'm sure I'm right.
No,
No, we'll see.
No, I asked you about if I forget about the power, and you say
Yeah,
it's okay.
it's okay. Once you put the power back before the square root, before you did the square root, you didn't.
Yeah.
That's the problem. Yeah. Okay. Physics. Ah. Right. Let's have a look and see the answer. Trust me, Fuan. Don't you trust me?
No.
Good. Should never trust. Should never trust a teacher.
I trust myself.
Good attitude. Is this not opening?
In the first step.
Yeah. Here we go. Right. What question number is this one?
11. Yeah.
Yeah. That's what I have.
Why my answer is
But it's right now.
when I calculate in here, it's right, but in here.
Maybe you were sleepy when you did it.
Yeah.
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 Okay, what was, let's check the last one. What was the answer I said for the E? Guys, the last question, what did I say the E was?
3.5.
Thank you. And what did I say the I was? Or the OR, sorry, the OR.
1.25.
1.25. I can do 3.5.
Did I make a mistake or did they make a mistake?
Yeah, we didn't multiply 2.4 to 6. I think he did it.
Oh, sorry, guys. Here, in the last one, I didn't type it in my calculator rightly. 2.75, thank you. I'm too smart to use this, so sometimes I make mistakes on it, yeah. Okay, what's the next electricity question then?
B2.
B2. Okay, I won't look at the answers. Right, the first one was define capacitance. What did you write down, Fuan?
I copied it.
Good, that's fine. You can copy it from your notes. That's fine. Okay, what's the next part? Part B.
Capacitors of value 2 farad, millifarad.
2 millifarads?
No.
Microfarads.
Microfarad and 3 microfarads and 5 microfarads are connected together in parallel. Determine their combined capacity.
Super easy for little babies. What's the total capacitance here?
Yeah.
What's the answer?
10.
10. 2 plus 3 plus 5. How many marks for that?
1.
Oh, 1 mark, okay.
No, 2.
2 marks.
Yeah.
Nice. Right. Next.
E. The same 3 capacitors are then connected together in series. Determine the new combined capacity.
So stupid. Right, 1 over C equals 1 over 2 plus 1 over 3 plus 1 over 5. You have the answer for all?
30 over 31.
For C or for 1 over C?
C.
30 over 31 microfarads. Okay. How many marks for that?
Also.
Right, next.
D. An 80 microfarad capacitor is charged to a potential difference of 20 volts. A. Determine the electrical energy stored on the plates of the capacitor.
Okay, so what's the formula for energy? Do you remember?
Half CV squared.
Very good. A half CV squared. A half CV squared. I got 2 over 125 joules. Yes? Or 16 millijoules. Is that what you got? This is my calculator. What did you get? Why not? What?
What did you do?
What did you do?
I don't know.
Okay.
Didn't do it D.
Okay. What's next? Did you get this, Mr. Sharif? No. Did
How
you?
did you know the C? It's 30 over 31.
This is it. It's given in the question.
The C.
Yeah? Okay, what's next?
The charging source is then removed and the capacitor is allowed to discharge through a large resistor, while the potential difference across the places of the capacitor is measured at 10 seconds intervals. The following results are obtained.
So we have a table.
Yes.
Do they want us to make a graph?
Copy
Yeah,
it,
but
complex the
not now.
original.
Now you have to,
Yeah, plot a graph of NV over V on the y-axis against P over S on the x formulas.
Only 4 marks for a graph.
Right.
Alright, let's make the graph. Go on.
The graph is
Wait, come
over
up.
T.
Wait. Huh?
The graph is T, not
Okay, what's part 2 then?
copy and complete the results table. That's the first thing. Right?
Oh, I see. They give you T and V, and then you need to figure out log.
yeah.
Right. Can you the T? What is it? Is it in tens?
Yeah.
Is the first one 0 or 10?
Yeah.
0, 10, 20, 30, 40,
Up to what?
50.
Okay, and the V's? Now hang on, the T is in seconds, and the oh come on. And the V is in V. And what to start with?
20, 19, 18.2.
20, 19, 18,
I two.
point 2.
17, 16.2,
Yeah.
15.6.
Okay, and to complete the table is they want the log of V,
Yeah.
which is in volts.
Why they said copy?
They want you to put it in your answer book.
So.
Draw this again.
Ah.
Easy peasy. What's next? Next is make the graph.
No, given that E equals V not E to the power minus T over R,
Yeah.
show that then V equals minus T.
Ah,
over
good.
tau.
This is the proof I was telling you about, which we did, the proof. So the question is to take this, is it like this?
Yeah.
Over R.
Over RC?
No, over tau, sorry, over tau, yeah.
Yeah. And the question was to prove the log formula.
Yeah, then V
Yeah.
equals minus T over
Do you need
tau,
me to
so-
do that or not?
No.
Yeah, you have this in your notes, don't you? So this is one of the proofs in the notes. Okay, so then what's the next part?
Plot a graph of then V in volts on the y-axis against T in seconds over the x-axis.
Hmm.
That's the graph.
Okay. And what's the formula for log V? That's log V0 minus 1 over tau T. Oh yeah, so that means the M is like the minus 1 over tau. That was what we said, yeah. Okay, so what do we put on the x-axis? The T, and on the y-axis, the log. Mhm. What question is this? B3, B2. The x-axis is time in seconds and the y-axis is log volt in volts. This is your graph? Now, what did they ask you to use the graph for?
The last question determine the value of the large resistance.
Okay,
And determine the first one for determine the time constant.
the time constant and then the resistance, right. So if you look here, which number do I need? The M or the C? The M here. So the M is minus 0.005. So minus 0.005 equals minus 1 over time constant. So time constant is 200 seconds. And then finally we have, do you remember the other formula for time constant? Awake? Why are you so tired? Were you working last night? What time did you go to sleep at? Why so late? True story?
Mm-hmm.
You were doing maths until 3 a.m.?
Yeah, just starting.
Why not doing physics until 3 a.m.?
No, I'm starting to revise.
Thank you. Somebody cares about me.
That's not healthy, Steve. That's not healthy, Steve.
Yeah, but a lot of homework. Physics and
Sorry, excuse me, are you like the homework expert or something?
I'm a health expert.
No, you are a how to have a good time expert, I think.
No, I don't even have with them. I'm serious.
Could have fooled me. Right. Or C is the formula for time constant. Do we know the C? I think they get, yeah, so we can get the or. What was the C? What was the C in the question?
nothing.
No, it was given. It was given at the start, wasn't it? 18 micro.
What?
At the very start of this
Yeah.
question.
What?
80 micro.
I do.
What?
That's it.
We are done with electricity.
Is there no more in section B?
No.
No.
Okay. Did you look at the solutions or you just tried them?
Oh God.
God. So intense.
Yeah, it's a serious. Relax. And it's the electricity. Okay, so we have the waves to look at.
But he didn't ask about the art, he just asked about the time constant.
I thought the next one was the or.
Steven,
What?
let's party. We
Yeah,
finished
where-
everything.
Oh my goodness.
Where will we go?
Don't be serious.
At
I
one.
don't-
Relax.
Do I look serious?
We'll go at 1.
Hang on. Let me just check the bus times, okay?
Okay.
Just relax.
In your division.